Go Language Programming, Chapter 1, Unit 1. History of Go Language. We will try to understand why Go language was designed. So, Go project was started by Google, and Google made sure that in this project, very experienced people are the one who work. So Google hired Ken Thompson, Rob Pike, and Robert Grismer was already working at Google on a different project. Initially, Ken Thompson is an American pioneer of computer science. Ken Thompson and Rob Pike worked at Bell Labs, and they were involved in the development of Unix. Robert Grismer is one of the initial designer of the Go programming language. Prior to Go programming or Go project, Robert worked on code generation for Google's V8 engine for JavaScript. And V8 engine is actually written in C++ by Google. So the main objective of Go language development was to make writing code fun and easier for the programmer. So Go specs were finished in 2007 by Google, and the Go language development team finished writing the compiler for the Go language by 2009. So Go language is basically based on C language and Java and Python. So if anybody who knows C very well, and Python, it would be very easy to learn the Go language. Basically, Go is a statically typed compiled language that generates the machine code. So, it is not like a Python. It is not an interpreter. It is actually a compiler. It's a compiled language. And statically typed means that during the compilation, basically everything is known about the its keywords, or how the memory is going to be allocated, what data types are used within the code, and so forth. Go also supports a native concurrency and garbage collection. Go is an after the Google decided that Go should be an open source. So all other companies uh, have been using Go language to develop many different types of applications, especially cloud-based applications, because it is it makes application writing very simple, very reliable, and the it generates a very efficient code. Go language also provides many other features that fit well with microservices architecture and data science. So nowadays, it's still Python is very popular among the data scientists. And one reason the Python is very popular is because it is quite easy to learn. Uh, it is a scripting language, and and um, the the only problem with Python is that when you write a Python code, it is basically you are if you are going to give Python application to somebody, you are giving them your source code with it as well. On the other hand, if you use a compiled language such as Go, only thing that you have to do is to give out the binary for your application. So let's now look at it, the how to set up the Go compiler for your uh, computers. In my notes, I am basically going over how to set up the Go compiler under Ubuntu Linux, because I do not use Microsoft Windows. I do not even have a Microsoft Windows at home, and I only machines I have is with the Linux. But if you go to this link right here, it will take you to or it will explain you how to install the Go compiler for under Windows or Macintosh or under Linux. So if you are installing the compiler under Linux, you just go and download this this file from this GoLang.org, and you untar it, and this tar command basically will untar under Linux, and if you are going to be using the because it's going to be installing this compiler under the as a root privileges, so you have to do the sudo command, so it will automatically will install under this path. So once the compiler is installed under this path, then what you can do is you can set up the environment for the compiler. So to set up the environment, you will create a workspace, okay? And you can give any name of the workspace. The workspace is basically a directory. So I'm just giving a name, go underscore projects. Okay, that's where all the workspace for the Go, all the things related to Go will go. So the workspace is made of 3 directories, and so compiler recognizes all these 3 directories. That's why the names of these directories must be exactly the same. So under the bin directory, which will contain the Go executable binary, meaning once you compile your applications, your binaries will go in there depending on how you compiled it. And under the src directory, you can put in your source files for your Go programs. And pkg is the directory which will store the packages. Now, Go language does have a package concept, so under this pkg directory, every package will have its own directory, and under those package names, all the package related files will be in that directory. So first, you can use Linux make dir command to create a complete work space path. So right here, by using this -p option with the make dir command, you telling the operating system that if any of these directories already exist, but if there are other directories which are not there, you just create those directories and just ignore the one that is already there. Okay, that's what this -p means. If you don't put -p and you just give this complete path, then what will happen is, if there is this directory, for example, a bin directory, and you did not put -p, then it is an error condition and the rest of the directories will not be created. So it will basically say some error has occurred. Okay. So once you create the workspace or the directory for the Go projects, you go in there, and when you do the ls, you should see these 3 directories in there. To compile the Go programs from the terminal window using the command line, you must add this path to your dot profile. Now, dot profile under Linux, since it's a dot in front of the file name, is a hidden file. So hidden means when you do this ls command, you would not see this file unless you do the ls -a, then you will see this file. So that's the only way to see all the hidden files. So basically, you need to be able to add this user local go bin path to in this dot profile. Okay, so this is the line that you should put in your this dot profile file, and what it is going to do is, when you log in, that this dot when you log into your Linux machine, this dot profile is the one which is first read. and it will set up the path, and basically it will export it. So also set the go path. So you need to set up. So this path is you're setting it for the purpose of um, accessing the executables from this directory. Okay, from any place in your Linux environment. So go path and go bin environment variable is a user in dot profile. uh, uh, you will have to basically uh, uh, give, and you need to add these two lines in the dot profile file as well. So this note says that if you install Go language in a custom directory other than the default directory, meaning if you didn't install it, we're talking about right here, if you did not install it in there, if you install it in some other place, you must specify that directory as the value of a Go root. Okay, so otherwise it's not going to be able to see your compiler, and you would not be able to compile it. Okay, so right here basically it is saying that, for instance, if you have installed Go language in home directory, you know instead of that path, the local bin, instead of right here, then you need to add the line below these lines in your dot profile file. Okay, these two lines. That is the reason. Okay, so this is the name of your Go compiler. Go compiler name is a Go. So the final step um, under this section is to be able to make sure, without rebooting Linux, you want to make sure that your dot profile or dot bash rc profile um, is um, um, whatever is in this dot profile is there. It all those these environment variables are set. So to do that, you use a source statement. Okay, which means make these environment variables, these go root and go path, um, put into the memory. So they are set for based on whatever the path that they are holding. Okay. Now once you do that, you need to make sure that you verify that your Go language compiler is installed properly. So if you did everything right, and from any place in your system, um, as a regular user, if you do the Go version, it will show you what version of the compiler that you have installed. And if you do the Go env, it basically will also show you the complete uh, Go environment variables on the screen. Okay, you can also type Go help, and it will display the information for different things, and basically this will give you a way to test if your Go installation is working correctly uh, 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 in your using your program, or using your text editor. Okay, so to test your um, your Go compiler, if it is installed correctly or not, what you should do is to um, copy this program, which is on the next uh, uh, slide, under this directory. Okay, under there is a directory. You should create the directory, hello directory, and under the hello directory you will have hello.go. Now whenever you have a Go program, that its extension must be .go. Okay, otherwise it won't work. So in in this slide, as you can see, this is a Go program. Simple. We will go over this program in the next slides, but just make sure that you type this in to test the functionality of your Go compiler, if it is installed correctly or not. And to compile this program, all you do is to use this command, go install hello.go. Okay, which will basically it will create this binary called hello under this directory called bin that we created earlier. Okay? So that's what it is going to do, and you can run this binary by just by doing this, go bin hello, and this program will execute, and you should be able to see the on your screen that this message will be printed, Go language installed successfully under Linux, if of course you did the install the compiler correctly. Okay, so this is how you set up the Go environment. Now Go, just like any other um, uh, compiled language, also provides different data types. Okay, so this is the complete list of Go data types. So Go has a Boolean type, it has a string type, okay, and then it has unsigned int, which is a 32 or 64 bits, depending upon your uh, processor size, the word size of your processor. Int is same as unsigned int, uint. Okay? And then this is a unsigned int pointer. So unsigned int large enough to store the uninterpreted bits of a pointer value. So as you know that just like C, Go also has the concept of pointers. Pointers meaning that if you declare a variable of type pointer, then that variable will only can hold the addresses of the other variables. Similarly, it also has int 8. Okay, so it's an 8-bit integer which will accommodate this the size will go from 0 to 255. Okay, and then int 16 is a 16-bit integer, and 32-bit integer, and 64-bit integer. So yeah, unsigned int 64. So so that's why, since it's unsigned, that's why this starts from the 0. Okay? If it would be a sign, so if it would be like 8, int 8, int 16, int 64, then it goes from negative to positive. Okay, and here you cannot store the negative numbers because you declared a variable of type this, and then that means you should have some positive number only. In here, you can declare a negative number. So it will take, for int 16 or int 32, it will take this big of a number from this range to this number. Okay, so it's a pretty big number that we are talking about right here. Similarly, Go language has a float as well. So it has a float 32 or 64. Now, the 64-bit, if you have created anything with a 64-bit variable, then you must make sure that your application will be running on a 64-bit processor, otherwise it will fail. It also has a complex 64 uh, uh, type integer. So the set of all complex numbers with float 32 real and imaginary parts. So you can create a variable of this type, or a complex one, 28. Go language also lets you have the variable of type byte. Okay, the byte is just basically is nothing but an alias of unsigned 8, which is we went over just now. Okay, that's a byte. So it will hold that big of a number from 0 to 255. And runny is an alias for int32. Okay, so this is like a new type that they came up with, and this runny actually represents the Unicode. Okay, that is the whole idea behind it, giving us some different type name, so it is easy to remember that it is a Unicode. It will store the Unicode. Um, uh, if you declare anything as a run E. So this was unit one, chapter one. We will um, uh, go into understanding what is all in unit two. Okay, so we will